To better understand how we use variables in programs, we need to take a quick detour and talk about the memory. And this is just going to be an overview, so this is going to stay super high level, and don't worry about it if you don't understand the details. But basically, over here you've got four main sections of the memory that we're concerned about. There's the program text, which is just basically all of your instructions written in binary. And then you've got your global data section, which are variables that exist outside of any specific function and are accessible to every function you write. You've got the heap, which is a place for dynamically allocated variables, which don't worry about that till you get to your advanced programming courses. And then you've got the runtime stack, which stores local functions and variables for you to access. So how does this work? So we're going to run this guy through a compiler, and it's going to create your ones and zeros for your program text, and that's going to be stored in this highest part of the memory. And that's basically all there is to that. Next, we've got global data variables, such as this variable e here, which exists outside of both main and potentially other things like func or printf, other functions. So this guy is going to go into the global data section so that it's accessible no matter what function we're in. And that's why I stored it in a separate place so it's readily and closely accessible. And then we've got the runtime stack. And so when we first call the function main, we're going to pop that onto the stack, and it's going to go down here, down at the bottom. And then once we create the variable pi, we'll put that onto the stack. And then we're going to call this function 1, so we're going to pop that onto the stack. And then once we get into function, we're going to create some variable x. We're going to modify it, play around with it for a little bit. We're going to increment it, print some things. And then once we're done with this function, what's going to happen on the stack is that x is going to get destroyed, the function is going to get destroyed after we return back over to here in our program so we know where we're going to our program. And then we finish off our main, and then these two guys both get destroyed because we're no longer running our program. We no longer need to store them in memory, and that memory is now freed for other programs. That's the basic gist of what's going on in memory. But to better understand that, let's look at this a little bit in detail with two examples. So in this example, you've got only the local variable int x equal to 0 here. And so that variable is available only to the function func. And to best understand this, we're going to run through the code, or what we call trace through the code, and just better understand how the memory is being allocated and when. So all programs, we begin with our main, and we're going to toss that location onto our stack. And then we're going to move on and call our first function. The location of func is going to be put onto our stack. And then it's going to tell us to go to this new function, func, and start executing those commands over there. So once we're in func, and while we're still in func, we're going to create some variable x0, and this is going to stay on your stack. And then you're going to print the value of x onto the screen over here. And then you're going to increment x, so that now x equals to 1. And once you leave func, and we're done with the func, it's going to get destroyed, and it's going to go away. Now, our stack tells us, oh hey, this is where we left off, so now we pick up here, and call func again, push this version of func onto the stack, go into the program, create our variable x, push that onto the stack, print the value of x, increment it, destroy it, and wash, rinse, repeat, call the function again onto the stack, initialize it, print it, increment it, destroy it. And and then we'll go to our return. So our return says this is the end of our main function, so our main is also going to be removed from the stack, and that's the end of that. Going back 1 second, is notice that since we created and destroyed x every single time, it always prints 0 because it always starts fresh. In this example, we're creating a different type of global variable called a static. So a static int x equals 0 says this is going to be initialized once across all functions, and it's going to reside in the global part of our memory. It won't be destroyed when func ends. So let's look at some of the considerations that you need to do then. because we initialize this here, what the compiler needs to do is say, okay, wait, I only want to initialize this once, so it's going to set some type of flag, like x init to 0, and it's going to make sure we only initialize the variable once. And then eventually it's going to keep checking to see, has it not been initialized? If it's not been initialized, then create it and then mark that flag to say it's been initialized once, so we never do it ever again. So that's going to be stored in memory in the global section. So this is, because of the static, it's in the global region. So this executes, although looking very similar, just one word different. It behaves very differently. So just as before, we start in our main, and what the compiler is doing behind the scenes is setting that flag. It was not in our code, but the compiler did that for us. And now we create our func. We call our func, push this guy onto the stack like before. He acts just the same, and then we start running code inside func. So the first time we haven't initialized x yet, so we're going to initialize it. So we initialize x. Hey, it's been created. Yay! And this is getting pushed into the global portion of our memory. And then we set this flag that x has been initialized, and we print 0 to the screen. We increment x, but now we don't destroy x, and it stays put after we leave func. But now we're calling a new version of func, or not repeat call of func. So now it goes through the stack. It says, oh wait, I haven't initialized my variable, so I'm going to skip over it. I'm going to print the value of x to the screen, so we've got that 1 now. Hey, it incremented. Our increment actually does something now. And we increment x again. Now it's x equal to 2. If we leave this call of func and it doesn't disappear, now we call func one more time. We go through this function. X has already been initialized, so we just print increment. X is now equal to 3. We go to this return. We're done here. So now, with this return being done, we take main off of our stack, and that's the end of our program. So as you can see, global and local variables behave differently depending on how we initialize our variables, how we create our variables, and what behaviors we give them. So this is important, and that concludes our lecture.